So now we understand a little bit about the energetics of the solution process. But how can we tell if a solute is extensively soluble in a given solvent? It turns out, based on energetics, that there's a simple rule of thumb that will help us with that question. In order for a material to be soluble, delta G of solution needs to be negative. In general, to get a negative delta G, you need delta H to be negative and/or delta S to be positive. From our discussion of bond strengths and enthalpy, a negative delta H is more probable if we are breaking weak bonds or forming strong bonds. Of course, in dissolving, we are talking about intermolecular forces rather than covalent bonds, but the idea is still the same. Weaker intermolecular forces would be broken in nonpolar materials, whereas stronger intermolecular forces will be formed with polar materials. The upshot of all this is that the best solute-solvent interactions occur when the polarity of the solute and solvent are similar. That leads us to a simple rule of thumb: like dissolves like. Using this simple rule, we can consider the characteristics of a solute and predict what it dissolves best in. For example, if the solute is nonpolar, it would dissolve best in a nonpolar solvent. A polar solute would dissolve best in a polar solvent. If we have an ionic solute, you might guess that it would dissolve best in an ionic solvent, but there aren't many of those, so we'll say that it too will dissolve best in a polar solvent. Let's see how we use this to compare solubilities. Consider these three materials: Ki, CS2, and Br2. Which of these, if any, are more soluble in water than in CCl4? Let's first look at the three solutes and try to determine if they are nonpolar, polar, or ionic. Ki with a metal and a nonmetal would be ionic. Br2, being a symmetrical molecule, is nonpolar. For CS2, we need to draw the Lewis structure. This would be a linear symmetrical molecule, so CS2 would be nonpolar. For the solvents, water is bent and polar, whereas CCl4 is tetrahedral and symmetrical, so it is nonpolar. We would predict that the two nonpolar solutes, CS2 and Br2, would be more soluble in CCl4 than in water. So to answer the question, only Ki, being ionic, would be more soluble in water.